Okay, so chapter 22 was all about hydrocarbons. Now we're going to cover chapter 23 just a little bit. This is functional groups. So these are when we add other elements to an organic compound. Instead of just hydrogen and carbon, hydrocarbon, now we have oxygens, nitrogens, halogens. We have other things added to the compound, and that creates totally different properties for the substances. So we're going to talk about 8 different categories of functional groups, and these are all their general structures, which you can get from your book. But I just want to make a quick note here. Each of these structures has an R in it, and in the book, the R is defined as any carbon or hydrogen. So a carbon chain or a hydrogen, but it is not that, okay? So I do want you to fix that. So R is any carbon chain or ring. Any carbon chain or ring. And I'm going to explain why it can't be a hydrogen in a little bit, but please, please, please make sure that this is clear in your brain. This can be a single carbon, it could be an ethyl, a propyl, a butyl. It could have as many carbons as we want coming off of this, but this is a carbon. It has to be a carbon. Okay, so up here, halocarbons. Halo is from halogen, so X represents a halogen, chlorine, fluorine, bromine, okay? Any of the halogens, and R, again, is some kind of carbon chain or ring. So we're attaching a halogen to a carbon. Alcohols, okay, alcohols are OH. If you add an OH to an organic molecule, to a hydrocarbon, you've now turned it into an alcohol. There's lots of types of alcohols. They're all toxic, okay, but OH, please keep in mind too, this dash right here is a bond. So this is OH bonded to a carbon. But remember, OH is 2 elements. So we could also write it this way. So we have a dash between the O and the H as well because they are bonded to each other, okay? So don't let this confuse you. This is the same as this. Okay, ether. An ether is an oxygen between 2 carbons. So in the middle of a chain or in the middle of a ring, you have an oxygen in there. That's an ether. Now this is why we can't have a hydrogen as our R. If I change this R to a hydrogen, this isn't an ether anymore. It's an alcohol. Okay, so R cannot be a hydrogen because that changes the type of functional group. It has to be a carbon. So ROR, ether. Okay, amine. We've talked about ammonia and ammonium. AM means nitrogen. So amines are a nitrogen group attached to a carbon group. So nitrogen, NH2, that's an amino group. All right, aldehydes. Aldehydes occur at the end of a chain because this last carbon in the chain has a single bond to hydrogen and a double bond to oxygen. That's 3 of its 4 bonds, and then it's attached to another R, another carbon. This case, this one could be a hydrogen. That's probably the only case that I can think of here that wouldn't change its functional group, okay? All right, so there we go. That's an aldehyde. Ketone. Ketone, we have that double bonded oxygen as well, just like our aldehyde. Now, I drew this double bonded oxygen pointing down because I ran out of space up here. I didn't want it to run into my subscript. So, but just remember, if it's a double bonded oxygen, it doesn't matter if it's up or down. It's still attached to that carbon, okay? So a ketone, you have a double bonded oxygen somewhere in the middle of a chain, okay? So carbons on both sides. If I change this to a hydrogen, it changes it to an aldehyde because that puts it at a terminal carbon. That's an end carbon, okay? So it has to be a middle carbon in the chain or in the ring that has a double bonded oxygen. Okay, carboxylic acid also has that double bonded oxygen and it has an OH. So this is kind of a combination of a ketone and an alcohol, okay? So you have that double bonded oxygen and an OH on the same carbon. So carboxylic acid, that's our carboxyl group. And then an ester down here, this is very similar to a carboxylic acid, but instead of being on the end, remember this is our terminal carbon, nothing can come after that hydrogen, okay? Here, we have it in the middle. You have a double bonded oxygen, and you have the ether group, that single bonded oxygen to that carbon, but we have carbons on both sides. So again, this one has to be somewhere in the middle of the molecule, okay? All right, so what I'm gonna do first, before I teach you how to name these, is I'm going to kind of show you what this can look like structurally. Okay, so I just drew a whole bunch of butanes on this whiteboard, okay? So bute meaning, hopefully you remember, 4 carbons. Bute is 4 carbons. Ane is all single bonds between those carbons. And then this is the complete structure, which shows every single hydrogen. Remember, every carbon has to have 4 bonds, And so each of these has the correct number of hydrogens to complete its 4 bonds to be stable. Okay, so I'm going to start with a halocarbon. Halocarbon, we've put a halogen onto a carbon. Now I can't just add a halogen to one of these carbons. I have to replace one of the hydrogens with a halogen. So if I go like this and I take this hydrogen away and then I go ahead and I add bromine to it, for example, that's one of my halogens, that makes a halocarbon. And I just put that bromine on the end carbon just because that's the one I chose, okay? Remember, we can draw a skeleton structure or a line angle structure here. 1, 2, 3, 4 points on this diagram makes 4 carbons, okay? So if I wanted to add a bromine to the end carbon, it doesn't matter which end, it would be the same. If I had chosen that end, it's the same molecule, okay? But if I wanted to add it to the end, I need to add a bond and then add my bromine, okay? If I were to just write a Br right here, that would change this carbon into a bromine. Only the points that don't have letters are carbons. And then when we add an extension with letters at the end, that's not a carbon, that's a bromine attached to the first carbon in a 1, 2, 3, 4 carbon molecule, okay? Similarly, I could have replaced one of these hydrogens with, one of these central hydrogens with a bromine, okay? So if I had chosen to do that, I might have done it right here, and that's what the skeleton structure would look like if I had attached it to my second carbon, okay? So please don't let the skeleton or the line angle structures confuse you. They just count the points. 1, 2, 3, 4. 4 points is 4 carbons, okay? And then I attached a bromine to the second carbon on this one. On this one, I attached it to an end carbon, which would be carbon number 1, because we always number to make things have the lowest possible location. Okay, alcohols, OH. Again, I'm attaching an OH to an R. An R is a carbon. So I can put an OH on the end or somewhere in the middle of a molecule, and I'm going to make an alcohol. So just by throwing an OH onto a carbon, OH, that makes an alcohol. Okay, so this would be 2-butanol, and I'm going to teach you the naming in a little bit. Okay, all right, ether, ROR. So this one has to be in the middle of the chain. Okay, so for an ether, I have to replace a carbon in the middle with an oxygen. Okay, there's a couple ways I can do this. I could erase this carbon and put an oxygen there, but it totally changes the type of molecule I have, but I'm doing that on all of these. So I'm going to go ahead and do that. Okay. So now if you count the carbons in that molecule, 1, 2, 3 total carbons, and oxygen between the first and second. Okay. If I wanted to keep my 4 carbons and put the oxygen in the middle, I can add my 4th carbon back on the end. Okay. Amine, again, an NH2 attached to an R. That's a single bond. It can just take the place of any hydrogen. It can go anywhere in the chain. If I want it to go on the end, I just add. So you might see it look like this, H2N, because the N is what is attached to the carbon, and so they would write it backwards if they put it on the left side. If I put it on the right side, I would have written NH2. If I put it on one of the central carbons, I would have written NH2, but again, the N would be at the other end of the bond, not the H. Okay, after an amine, aldehyde. This one has to be at the end of the molecule, because again, that carbon has a double bond oxygen and a hydrogen. That's 3 bonds. It only has room for 1 more, so it has to be at the end of the molecule. So an aldehyde, if I wanted to add my double bond oxygen here, we usually write the hydrogen as well, just so that we can see the whole functional group. Okay? All right. After aldehyde, we have ketone. That's just a double bonded oxygen somewhere in the middle of the chain, because it has R's on both sides. So a ketone could look like this, just a double bond oxygen on that carbon, or I could have done it down here. Okay? But somewhere in the middle, so I only had 2 options on that one. Carboxylic acid has to be at the end, okay? And again, end can be the beginning end or the end end, okay? It does not have to be at the right end of the molecule like I did with the aldehyde. It can be at the left end of the molecule. Double bonded oxygen and an OH. And so if I were to do that at the left end, double bonded oxygen and an OH, remember the O is what is attached to the carbon. So this is a carboxylic acid group right there. Okay, and then finally we have our ester. Just a refresher right there. in the center of the molecule, we have a double bonded oxygen and a single bonded oxygen on the same carbon. Okay? I'm going to go ahead and just put it here. So what I'm going to do is I'm going to put my double bonded oxygen right there and put my single bonded oxygen here. But this right now is not the middle of the molecule, because if I don't draw anything else, it is assumed to be a hydrogen, and that would make it a carboxylic acid. So I have to add one more bond to show that there's a carbon on this side. So 1, 2, 3, 4 total carbons in this ester. Okay, now I'm going to go through naming. So hopefully you've already opened up the class notes part, or the file that was kind of with this video, okay? And have already started to fill in the data table, not the data table, but the notes table on how to name these functional groups, okay? So what I have is I have an example molecule for each of these, and I did a carbon skeleton. So I showed all the carbons as C's, and I did not show the hydrogens. But remember, all of these would have hydrogens to fill up their 4 bond requirement for stability. So if you need to pause the video to copy all of these structures down, please do so. And then I'm going to go through and name each one using the rules that you already copied down from that file. Okay, so we're going to start with the halocarbon. And halocarbon, we've taken a hydrogen away and we've attached a halogen. So the halogen is a branch off of the parent chain. Okay, so what would this be called if it didn't have that halogen? If this was just 3 carbons with all single bonds, we would call it propane. Okay, so I'm going to write propane out here. Okay, propane. But I've attached a bromine to it. And if I were to number this, whether I go 1, 2, 3 or 1, 2, 3, that bromine is attached to the second carbon in either case. So it's attached to carbon number 2. We have to give its location and we have to name it. Now, normally a branch ends with the suffix YL to show that it's a branch. But when we're talking about halogens, it's going to end in O. So instead of bromine, it's bromo. So this is 2-bromo propane. 2-bromo-propane. That's the name of this molecule. If this had been a fluorine, it would be 2-fluoropropane. If I had put the bromine over here, it'd be 1-bromopropane. Okay? So just, you have to give the location, name the halogen with an O to indicate that it's a branch, and then the parent chain. Okay, alcohols, very similar, very similar. Instead of a branch though, we're going to change the ending of the name. We still have to tell where it is, because I could have attached that OH off of the second carbon instead of the end, okay? So if I number, again, that's my parent, my propane. If I number this 1, 2, 3, the alcohol group is attached to the third carbon. If I number it the other way, 1, 2, 3, the alcohol is attached to the first carbon. Take priority. Always number your substances, parent chains, so that the attachment or the change or the branch is attached to the lowest possible number carbon. Okay, so 1 is my location. Okay, now if I didn't have that, it would be propane. I'm going to take off the take off the E, and I'm going to add OL for alcohol. So alcohols are going to end in OL. So propane, there's propane. Just take off the E. Don't take off the A, just take off the E, okay, and add OL. 1-propanol. 1-propanol is the name of that alcohol. Okay, ether. Ether is our oxygen in the middle, okay? And with ethers, we name the carbons as branches. So I have a branch right here, and I have a branch right here. And when we have carbon branches, the way we name them is based off of the number of carbons for the prefix and YL as the suffix for a branch. So this right here is an ethyl branch because it has 2 carbons. This is a methyl branch because it has 1 carbon. And if you remember from branched hydrocarbons, we name our branches in alphabetical order. Okay, so ethyl is before methyl in the alphabet. So this is ethyl, methyl, ether. So ethers actually end in the word ether. Ethyl, methyl, ether. ethyl methyl ether. Now there is another way to name ethers, okay? And that is to take the longer side and call that your parent. And the shorter side is the branch, but it's going to end in oxy. So this becomes the branch in the alternative method. And because it has one carbon, it's a methoxy branch. And so this is my parent, ethane, methoxyethane. If you want to write that, you can. That is an acceptable naming system. It's just less common. So methoxyethane is the other way to name this. I like ethyl methyl ether, but methoxyethane will work. Okay, remember the longer side becomes the parent, the shorter side is a branch with oxy. Methoxyethane. Okay, amines. Here I have an NH2 attached to a carbon. I could have put it anywhere. A single bond means it could go in the middle, it could go on the end, I could have put it anywhere, okay? So I have to give location, and hopefully by now you've gotten used to the fact it needs to be on the lowest number carbon, so this would be carbon number 1, 2, 3 instead of 1, 2, 3. So 1, okay, and then we're going to take our parent chain and we're going to change the ending, okay? So, well, I guess there's two ways. Let me focus on the primary way, okay? We're going to say that actually the amines end in amine, okay, is attached to a branch. So this branch has 3 carbons. That would be propylamine. Propylamine, okay? If I want to use the other naming system, it's going to be very similar to up here where I change the ending. I take propane, take off the E only, and I add amine to it. But either way, it's going to end in amine. So this would be propanamine. Now we're going to stick with the amino group being on the end. I know I spoke earlier and said that I could put it in the middle, and I can put it on the middle, and then it becomes an amino attached to a parent chain. But we're going to stick with this naming system. So propylamine or propanamine with the amino group on the end of a chain. Okay, aldehydes. Aldehydes are going to end in al. Okay, aldehydes end in al. So we're going to change the ending of our parent chain to al. Just the E, take off the E, add al. Now, aldehydes have to be on the end. That's 3 of the 4 bonds, so it has to be on the end carbon. So we do not have to share location. It has to be on the end, so that would be redundant to put a 1 next to it. So this one, instead of propane, becomes propanal. Now, if you were to have seen this word before today, you probably would have pronounced it propanol. But remember, up here, this is propanol. So propanal, we have to make sure that when we pronounce these things, we change that A to a short A. Okay, propanal for aldehyde. Okay, ketones. Ketones end in -one. These have to be in the middle of the chain. Now, in a 3-carbon chain, there's only one place to put a ketone group. But if we have 5 carbons, 6 carbons, if we have a longer molecule, there's multiple options for where that can go. So we do have to give the location on those longer molecules. So on this one, if you didn't give location, that's okay. But for the purposes of your notes, I want to just go ahead and throw a location in there so that you know you're supposed to on longer molecules. So that ketone group, that is on the 2nd carbon. So 2 is my location. Again, propane, but take off the E. Okay, so propane without the E, and we change the ending to O-N-E. Propanone, 2-propanone. Okay, carboxylic acid, okay? Carboxylic acid. It's almost going to end in ic acid. We're going to add an O, okay? So they're going to end in oic acid, okay? And again, this has to be at the end, so we do not have to give a location for this one. So this is going to be at the end. And this is a propane, if I were to take all this fancy stuff off of here, propane. So propane without the E, and we're going to add oic acid to it. So that one's a little bit weirder. Propane, no E, oic acid. Propanoic acid. Okay? Now finally, ester. Ester has 2 parts to it. This part over here is attached to both oxygens and then continues, and this, in this case only one more carbon, but it could continue a lot longer than that. And this part over here is only attached to one oxygen. So what we do with an ester is we take that side that's only attached to one oxygen, and this is the branch, okay? This is my parent over here, the part that's attached to two oxygens, and all the other carbons on that side are the parent, okay? So my parent would be ethane if I didn't have this stuff attached to it, but we're going to change the ending of that. And then my branch is just a branch. So single carbon branch is called methyl. So I'm going to go ahead and put that on here, methyl. And then ethane without the E. And we're going to add an ending for esters. And esters have the weirdest ending. It's not related to their name at all like all of these ones are. It's OATE. So methyl ethanoate is the name of this ester. Methyl ethanoate. I could have just as easily put this carbon over here, and then I would have had an ethyl methanoate, okay, if I moved this carbon over. But it's just whichever one is attached to both oxygens, that's the first carbon of your parent. And in this case, it only has two carbons. Then my branch over here, only attached to one oxygen, only has one carbon in this case, but it could have many more if I added, if I made that chain longer. Okay, so methyl ethanoate on that one. So there's a brief overview of naming hydrocarbons with functional groups. Probably pretty complicated, it might seem like that to you, but we're not going to expect a ton of memorization on this. Mostly you need to be able to recognize your functional groups and kind of know what they end in so that you can kind of match them to the right names when you're looking at compounds and their structures. So thank you for tuning in, and we'll see you later.